Hello, everyone, and welcome to GlugNet. My name is Stephen Ball. I am the president of GlugNet. Tonight, we are pleased to welcome Matt Kelly-Williams, who will be speaking to us about agile and sustainable development practices. But before we begin, a couple housekeeping things. Once my slides will advance, there we go. First, a little bit about GlugNet itself. We are the Greater Lansing user group for .NET developers, currently based out of Okemos, Michigan, as pictured here. Our meetings are held every month on the third Thursday, free and open to the public. The best way to find out more information about upcoming meetings is to visit our meetup website, meetup.com/glugnet. First of all, housekeeping wise, we are looking for lightning talks before the featured presentations. If you are interested in giving a 10 to 15 minute talk on a tech topic of your choice, if you could let either myself or Joe Kunk know, we will get you slotted into a meeting in the future. Tonight's presentation, we want to be interactive. So if you have any questions, feel free to jump off of mute and ask your questions. There's also a chat feature in GoToMeeting that we'll be monitoring for questions as well. But we ask if you are not asking a question or answering a question from our presenter, that you please remain on mute so that everybody can hear and enjoy the presentation. Finally, at the conclusion of our presentation tonight, there will be an anonymous survey available to all attendees. This is looking to give GlugNet feedback on how we are getting the word out about our events, as well as how Matt did on his talk. And all of that feedback will get summarized and sent to Matt at a later point. So if you would please consider leaving your feedback at the end, we would very much appreciate that. Our sponsors this evening, NIS Technologies, who is providing us this GoToMeeting session, and the .NET Foundation, who helps pay the bills for the organization. Meetings are typically recorded and posted to YouTube by Sam Nasser. A link to his channel and a QR code is on the screen now. If you enjoy this group and you're looking for something similar, we have some other groups in the area you might consider. In Cleveland, there's the Cleveland C# user group. There's the Greater Lansing area for SQL Server, otherwise known as GLASS. There's a .NET study group. And if you are in the Southfield, Michigan area, there is MI.NET. They are currently only in person though, so you have to be in the area to attend that one, unfortunately. So now, without further ado, time for our featured presentation.
So this evening I'll be talking about Agile and sustainability, Agile methodologies or approaches to sustainability that are pragmatic, and it's something that I'm very passionate about. You may have seen me at other conferences. I also spoke here in GlugNet back in November. But I will next be in your neck of the woods in May at StirTrek. Let me just quickly plug StirTrek. It is a great one-day conference. It is in Columbus on the first Friday in May. Slides for this will be available. I haven't dumped the PDF on this version, but there are other versions. But I will get that updated later tonight or tomorrow. So why am I here? A little over a year ago, was talking with somebody at a conference in Columbus, and we started talking about sustainability. And in the midst of it, asking him some questions about what sustainability meant to him and so forth, I found out that at this point, very few people, if any, are talking about things that individuals' software and architecture that they build, how that can affect sustainability. And so this became very much a raison d'etre. It's almost an obsession. It's something that I feel very, very strongly about. And ikigai, sorry, is a Japanese term and philosophy that basically means reason for being. And so I am very much dedicating time and energy to promoting sustainability in IT at this point. So let's start. People are like, what is sustainability? And basically, sustainability in IT are practices that we would use to meet our current tech needs, but without compromising future resources. And we'll go into more details on that. But a lot of companies, are having issues trying to figure out how do we go about doing sustainability. So I'm going to propose here a very simple 3-step plan that any organization can put into effect. Step 1, we're going to talk about sustainability. Step 2, we'll come back to that later. Step 3, we're going to save the world. Unfortunately, a lot of companies at this point are basically ignoring it as much as they can. This is changing, however, as regulatory requirements come into effect. More and more companies will have to take sustainability into account in their operations. There's a lot that I could cover in this talk. Parts of it I'm going to gloss over. There's a number of resources at the end. I really suggest that you download the PDF and can go through it at your leisure and learn more about it. But if you take away nothing else today, be pragmatic. It's been said that the perfect is the enemy of the good. It's no less true in approaching sustainability. Rather than creating an elaborate plan with lots of complexity, it's better to address and talk about things which you can do now in order to make an immediate effect, a win, if you will. Once you have a win, it's easier to gain support from others and build a larger initiative and grow from there. I mean, we've all seen these huge IT initiatives that new management comes in and says, we're going to do this, and in 18 months, we're going to. And unfortunately, most of them fail. The idea behind what I'm talking about tonight is incremental. It's baby steps, but once you start taking steps, you can build on them. Make better choices. Now, we do need, within the constraints of the business, to make our choices. You could have something that works okay, that you can write in an afternoon, and it needs to run, say, once a month, and it takes 10 minutes to run. Or, by the same token, you could have the same end result that runs in a minute that took you 3 weeks to write. It's all of this is about making better choices, finding ways of improving your efforts, being cognizant of what your code does, understanding how your infrastructure and your architecture works. It's important so that you can understand the associated costs and make decisions based on costs and limitations. Sometimes it's just as simple as making a good choice over a bad choice. Sometimes it's language that can make a difference. There's a lot of different pieces that go into this. And reduce your pain points. Make small, gradual improvements. Don't try to, slam everything all at once. You'll be able to see more results over time if you make small changes. Make a small change, see what effect it had, and then find another thing, make a change there. You'll also reduce risk by doing so. And it's a journey. It's not something that you're going to be able to do overnight. It's not something that you can overnight or, in a year say, we are now sustainable. We are now, carbon neutral. It takes time. It takes a lot of effort. It takes buy-in. It takes commitment from all levels of an organization. That said, however, it doesn't mean that there aren't things that individual contributors within an organization can do. So why does sustainability matter? What's important about it? Well, you may have heard about climate change going on. I think at this point, most people will agree that yes, indeed, the climate is changing, that things are getting hotter, rainfall's changing, the oceans are heating up, and so forth. Now, not everybody will agree that we are responsible for that, but even if you don't think that we are responsible, there are still things that we can do to minimize our impact. And by minimizing our impact, we would not be making it worse. So what sort of things does IT impact on sustainability and in terms of the environmental footprint? Well, there's energy consumption. Bitcoin mining, crypto are all large users of energy. In the last year or so, as AI has become popular and LLM models have become, more and more available and popular for people, the amount of resources being used in order to support these efforts is quite large. E-waste, cell phones. How often do you replace your phone? It seems like anymore, the phones die after a couple years and then need to be replaced. The global footprint of cell phones in terms of the electricity it's using just by itself between 2019 and 2022 doubled to up to approximately 5% of the world's energy use is just for cell phones. IT's carbon footprint. By 2040, it's believed that IT will account for 14% of the world's carbon footprint. Right now, we're at about 8%. And to put that into perspective, that is about the same carbon footprint as the world's airlines. Other resources, water, for instance. Between 2021 and 2022, Microsoft increased their water consumption by 36%. It is believed that the majority of this was due to ChatGPT. To put things in perspective, if you ask ChatGPT, depending on the complexity of the question, anywhere from 5 to about 30 questions will consume a pint of water. And I'll admit I use ChatGPT for a lot of things. But again, it's a matter of doing things in moderation. Trees are also being cut down. Pollution, raw materials. So a 2 kilo laptop requires 400 kilos of raw materials to just build the laptop. It's an incredible number. So what are the ways that people are measuring the environmental impact of an organization? And this is something that is now being required in Europe. California has also some requirements for ESG reporting. India will soon as well. And later this year, the SEC is supposed to be releasing requirements for publicly traded companies to provide reporting on their environmental, social, and governance impacts. So on the environmental side, we have things like climate change, greenhouse gas emissions, biodiversity loss, and so forth. In terms of social, employee safety and health, working conditions, conflicts and humanitarian crises can also be under social. So is your company or your organization involved in a part of the world that's seeing conflict? For governance, there's corporate governance, trying to prevent corruption or at least reduce it. The diversity of your board of directors. How is your executive team compensated? All of these are things that go into ESG reporting. And like I mentioned a moment ago, it is becoming required. There are regulations that are going to require organizations to report on their ESG initiatives, efforts, costs, so forth. And I believe in this country, at least, and I expect it's true elsewhere as well, that the main driver for the adoption of some sustainability practices is going to be regulations. There's also, at least in some parts of the country, a certain amount of social reputational cost involved. But my landlady here works for a company whose business model is to use geothermal for heating and cooling of factories, as well as producing energy for the factory. And they have been extremely, extremely busy of late, where companies have come and said, we made this claim that we could save or reduce our carbon footprint by X%, and we can't meet it. Can you help us? So I really think that as time passes and as the more and more regulatory organizations start requiring organizations to think about sustainability, that this will become more important and more visible. So why does it matter to IT? Well, IT in a lot of organizations drives outside of, say, manufacturing organizations or shipping or supply chain. A lot of a organization's carbon footprint is because of IT. It's been said that every organization is an IT organization or has part of its organization that does IT. It's that ubiquitous now. So a lot of these practices really affect every single organization that's out there. In the midst of this, for having reporting and such, individual groups within IT are the people who tend to have the numbers. And as a result, they can do the reporting. Another potential driver for sustainability initiatives is FinOps. And FinOps is something that has been very much in the news in the last few years. I expect it will still be around for a while. There are some people who are saying that green ops is a part of FinOps. I don't agree with that assessment, but because you can have green initiatives outside of finance, but FinOps could be a driver for increasing efficiency. Now, they're coming at it from a cost savings perspective, but nevertheless. So about this time last year, very much in a if you build it, they will come sort of moment, I threw out on LinkedIn a draft manifesto just to see, if there was going to be any traction and see what people thought and so forth. I totally cribbed it off the Agile manifesto. I freely admit that it was very much inspired by it, but it has gained some traction. It is the basis for the foundation for a green computing foundation out of India, and all of their methodologies and practices are built on top of this manifesto. So I'm just going to go through it pretty quick. There's 12 points. If you go to sustainableitmanifesto.org, you can read the manifesto. And if you care as an individual to sign it, you can do so there as well. So we are going to prioritize energy efficiency over raw performance. Now, that said, there are places where we need the raw performance. One place would be, NASA or SpaceX. The stock exchange needs, at least as it is working at present, to have, real time, and they measure things in microseconds. But outside of that, does it really, really matter if your batch job takes 5 minutes or 10 minutes to run? Probably not. We're going to try to be more efficient with our resources. Over my career in IT, particularly over the last 20 years or so, I've seen more and more people who work in IT who seem to believe that RAM, CPU, disk space, network are all infinite. And they're not. And again, you do need to have a good balance between business needs and efficiency. But rather than having a bunch of machines that are sitting there idle but running all the time, do things like virtual machines where you can more effectively use a resource. If you see a certain amount of traffic during the day and it drops off at night, well, shut down some of the servers or shut down containers. Do you need your entire CI/CD platform running 24/7? You might not. All of these things are things to take into account and making decisions. And it's about making better decisions. We want
Yeah, Matt,
to.
can I ask you a question about that previous slide?
Mhm.
Yeah, so your point about like spinning up the VMs and stuff, I think is interesting because in my mind, in my mind, you say, all right, we're going to only run the VMs when we need it, or we're going to add capacity when we need to because our website's getting a lot of traffic, right? And that makes sense. But then I also think about, well, okay, all that stuff is running in the cloud, and we just talked about all those stats about how much compute that the cloud is taking up. So at some point, do those two kind of offset each other?
They can, yes. So recently, like within the last year, um, government in Scotland, who had all their own data centers, were looking at using resources more effectively, and so they went to the cloud. And it definitely there can be wins by going to the cloud because the cloud providers are going to be utilizing their CPUs and so forth, and just the resources in general, a lot more effectively than a local data center. In your local data center, you are going to have some excess capacity. Now, whether this be from, um, you know, planning to have it so that, when peaks happen, you can accommodate, or if it's just because things weren't sized properly. It could be for a number of reasons. But in this particular case with Scotland, a lot of the energy that the Scottish data centers were using were air or wind and wave power. So they were definitely renewable sources. The data center that they moved their processing to was down in England, and their electricity was generated by coal. So in doing so, they basically had a larger footprint when they were done. And like I said, a lot of this is really being pragmatic. Know your systems, know how everything works end to end, and have a good understanding of that. Did that answer your question?
Yes, absolutely. Thank you.
Yeah. So I should probably say, at the start of this, that I'm wearing my architect hat because a lot of the answers that people are to questions that are, it depends.
The classic IT answer.
Oh yeah, but it does. Sometimes a sequential search is the fastest, depending on, the overhead of quicksort and some of the other sorts. Or, in quicksort, if you're sorting an already sorted set, it slows it down badly. So we're also going to try long-term sustainability over short-term gains. Rather than concentrating on the stock price and stock dividend for the next quarter, let's look a little further out and make decisions that, may not provide immediate financial benefits, but provide benefit over the long run. And this is both in terms of hardware and software design. We want to have a holistic impact awareness. We want to tear down the silos. And you've seen this probably in other places, such as Agile teams that include testers and DevOps and so forth. Anything that you can do to promote understanding and considering the broader impact of your decisions, whether it is dealing with software logic or hardware assembly, it all impacts across the organization. And so it comes down to communicating with people. Every business is there to make money. If they aren't making money, then they cease to be a business and they die. So we need to have profitability, yes, but we can't just exclusively pursue the dollar. We need to take other things like the environment under consideration. We also need to make decisions together. This goes back into the holistic versus silos, but having diverse perspectives, software engineers, hardware technicians, etc., working together and looking at what they are producing and the impact that it can have on the environment. And again, a lot of these things are gray areas. Make a choice that is a better choice, and you can move forward and you can make progress. Anybody remember or see when they were younger those puppet and claymation holiday specials? There's one, the Kris Kringle, I think it's called Santa Claus Is Coming to Town, where one of the characters had not really done much for a very, very long time and had kind of atrophied. And, there's a song, just put one foot in front of the other, and soon you'll be walking across the floor. Put one foot in front of the other, and soon you'll be walking out the door. Just by making those steps, one after another, we can make a difference. And this point will definitely appeal to, agile methodologists. Things happen. There are things that we know, that there are things that we don't know, and there are things that we don't know that we don't know in the process of creating our projects. We need to have flexibility because, things change. Additionally, and this is one of the things that regulations are going to drive, I believe, we need to be able to have transparent reporting as opposed to selectively cherry picking numbers. It's been said that there are lies, damn lies, and statistics. Cherry picking numbers for your reporting to make yourself look better than you really are is not a good process or a good practice in the long run. It usually will get found out, and the cost is usually higher than if you'd made the initial reporting more honest and open. Additionally, new stuff comes out, new knowledge, new methods of doing things. There's a talk that I've given on data structures and algorithms where there were some searching algorithms in it that I discovered in the process of doing my research that I had never heard about, and they were 40 years old. 40-year-old searching algorithm that I'd never heard about. We need, as practitioners, as craftspeople, to improve our skills. And it's been said that if all you have is a hammer, everything looks like a nail. The more tools we have, the more proficient as craftspeople we can be, and the better choices we can make. We also want to, take into account the community. A lot of parts of the world, we have recycling in some parts of the US. Unfortunately, at this point, what happens to a lot of that recycling is it gets compressed, put in a container and shipped overseas to some third world country. And we need to recognize, our impact and what our choices are. Make eco-friendly materials a thing. Rather than having a flimsy, breaks as soon as you drop it, cell phone, for instance. Build something that's going to last a bit better. Choose things that are recyclable or have a more minimal environmental impact. We also want to choose for device longevity over planned obsolescence, where it makes sense. For things that are doing serious number crunching, okay, having a shortened cycle does make sense. And the power utilization of newer CPUs in terms of the number of operations that you can make for a certain wattage has decreased over time tremendously. But this also takes into account, what do you do with your hardware after you've decommissioned it? Do you recycle it? Do you donate it to groups that are, say, schools or clubs or other organizations that can make use of it? These are all things to take into account. So we all have a role, all of us in IT, but everybody in general has contributions that they can make to sustainability. And I'm going to jump through this next bit a little quickly. Again, feel free to download the slides and take a look at them. But
Matt,
this steps,
We had one
yep,
question there. What was the name of that search algorithm that you found that was 40 years old?
called a galloping search. And so the galloping search is useful for unbounded searching. So say something like a log file that is unbounded on one end. And the way that the galloping search works is by having a sliding window. You check, all right, so you have a window, say at the start of the log. Are we within our search criteria? No. Okay, let's move forward, increase our window slightly. Are we? No. And so forth until you've bounded it, or you're beyond the bounds, or have hit the end and there's nothing left to search. Once you've got your window, then you use a binary search within it. So, that was very interesting to me. Another algorithm, well, more data structure, but there's some algorithm involved, is something called a cuckoo hash. Now, cuckoo birds have a tendency to lay their eggs in the nests of other birds. And the cuckoo tends to hatch first and is bigger than the other birds. And what the cuckoo does is kick them out. And the way that a cuckoo hash works is, because rehashing a hash is very expensive because you have to recalculate the hash for every single element. The cuckoo hash says, okay, if I get a collision, I'm going to push out what I'm colliding with. And I have another hash over here that uses a different hashing algorithm. And we then will put the element in there. There's another variant on it called the peacock hash. And the peacock hash says, well, if one other hash is good, then more than one is even better. And the peacock hash was actually being used in real-time ARP tables, address resolution protocol, for routers and switches. And what they found was that the MAC address space is a very large data space, but with each subsequent hash, it could be smaller. And so by the third or fourth hash, it could have 10 elements or less on it. And they were doing real-time, constant time inserts and lookups within these hashes. Constant time, that's the mecca. That's where the gold is. If you can have an algorithm that's running in constant time. And it was fast enough to keep up with very, very, very large switches and all of the addressing that the switch needed to do. So that's a couple examples of things that I had never heard of prior. one I'll leave you with. It's another search that I had not heard of, but I don't remember when it was invented. But if you ever look in a dictionary or a phone book, back when we had phone books, you wouldn't start at the very beginning. You'd make a guess, right? You would guess, oh, I think it's here, and then see where you are. And then you'd make another guess until you've narrowed it down and you're finally on the page of what you're looking for. And this is called a heuristic search. And in some cases, the heuristic search runs in log of n as far as its big O notation goes. So it's really in some cases, the most efficient search that you can have. Now, it presumes that you have an equal distribution across the size of your data set. But if you don't, it still will be as efficient roughly as a binary search. So it's still pretty good, but it just could be much better. Answer successfully or appropriately?
Yes, I believe so.
All right. Well, let's see how individuals in IT can all contribute to sustainability. Scrum masters and agile practitioners can facilitate sustainability. Have as part of your retros, talk about, what could we do here? For some of your tech debt, look at some algorithms or some code that might be less efficient than it could be. Now, again, be pragmatic about it. But this is one place where agile practitioners can help facilitate sustainability. Analysts, optimize your data center, track metrics. And of course, the metrics also apply to DevOps, but also, creating a energy efficient infrastructure also falls under DevOps. At this point, I can remember where people would put in requests for a disk drive, and it might take 6 to 9 months before the request went through to be added to, increase the size of the SAN. But nowadays, things have gotten a lot cheaper, gotten a lot easier. And with the cloud, you just say, hey, I want a VM instance that's this size with this amount of RAM and this amount of disk. As far as the 3 ways go, the 3 ways are a set of principles that were created by Gene Kim. They show up in the Phoenix project. And the first way is find things that are preventing you from delivering value to your customer, and then fix one. And repeat until you have straightened out at least the first set of road bumps. You'll find more later, but and go from there. The second way involves fast feedback loops. Anybody ever work on a project where they push code and the testers would get to it eventually? Of course, the development teams are not quite on schedule. They're running behind. And so, the testers have 2 weeks to test everything. And so they'll go back through and, oh, you checked this in and it's a bug and it's from 6 months ago. So you then have to try to remember, what was I doing? What was I thinking? Whereas if you do things like the tests, regression tests or, other testing closer to the developers, this is also called push left, then they won't be so pressed to try to remember what they were doing when they wrote the code 6 months ago 2 weeks ago, as opposed to, 15 minutes ago. The third way is, and Gene Kim describes it as creating an environment that promotes experimentation and learning. I like to look at it as, continuous improvement. Now, along those lines, you might need to do experimentation in order to be able to see if you can improve. But just being able to play doesn't mean that you'll see any improvements. And I see the chat comment numbers going up. So does anyone have a question?
Oh, no, I was just agreeing with your point that I've constantly seen that happen, particularly with fixing data in SQL Server, where we'll apply the data fix and it sits there for a while, and the tester comes back and says, "Oh, this is wrong," and we have to go remember what exactly we coded in that script.
Oh yeah, yeah, and it's hard. Now there are some development practices that can help. One is maintenance-driven development. And the idea here is that you write your code as if 6 months, 2 years down the road, you're the one who's getting the call at 3 a.m. Or better yet, the person who gets the call knows where you live. Now, does this not mean that there are places where you perhaps should be clever when writing your code? Yeah, there are some potentially. But if you start out writing the code clever and not maintainable, maintenance of a project is about 90% of the total cost of a project historically. And if you don't make it easy to maintain, but start out by being clever, you're basically falling into a premature optimization trap. Developers, energy efficient coding, and where it makes sense, serverless computing. Now, it might make more sense to have a monolithic container that's running and having several of those, as opposed to something like a Lambda that gets triggered. It really depends. And understanding your application and its needs really should drive this. End user support. A lot of it here is, educating users, helping them have more efficient settings. Hardware designers, create hardware that uses less power. Back in 2016, after having been burned many, many times at conferences, as well as wanting to have a laboratory, I built what I called a cloud in a box. And it consists of a 24-port gigabit switch with rack-mounted Raspberry Pis. There's about 20 of them in it. There's a USB-powered firewall/Wi-Fi and 8 or 10 SSDs in it. And so all told, there was about 40 core sitting in this, and it was a hybrid, heterogeneous of different versions of the Raspberry Pi. And just sitting there, everything started up, it would draw 45 watts, which is pretty amazing. But again, there's limitations there. The Raspberry Pis at that point were limited in terms of their I/O. So there's trade-offs, just like everything else. But having a 40-core machine with 20 gigs of RAM and sitting there and just drawing 45 watts, you'd be hard pressed to do that with different architectures. Leadership needs to set goals. They need to set KPIs and OKRs around sustainability. But more important, they need to make decisions that promote long-term sustainability. Individual development teams and individual projects can make their individual projects more efficient. And in the process of making it more efficient, frankly, they're going to reduce costs. But that said, unless leadership buys in, then the changes that individual teams will be able to make are limited. Managers and project managers need to help promote sustainability, how they go about the projects. Also, vendor selection. You know, is your vendor doing good practices? Are your vendors, how does the supply chain work? How efficient is the supply chain, and so forth? Product owners, they need to allow a certain amount of time for implementing, and I'm going to refer to it as tech debt, or green debt, if you will. This is a part of the whole process. And, there's always a certain amount of pushback for tech debt and so forth. There was one project I worked on at a company where we had a bunch of tech debt that had accumulated that made deployments painful and so forth. And what really, really turned that around was having the developers be primary on call, so that if there was an issue, they would get the text first. And, if for some reason it was having to do with something that they couldn't handle or didn't know, then there were, other people who would jump in. But by making things a shared pain, then they pushed back to the product owner saying, no, I know you have all these features you want, but we need to spend time on our tech debt. QA. One thing that QA might look at is how efficient are our tests? How many copies of data do we have? Are we spinning up and spinning down, testing boxes as needed? Another potential question to ask would be, do we need to run a full regression test every time somebody checks in code? And the answer, of course, is it depends. Now, if you have regulatory requirements, say you're a bank or a nuclear power station, then yes, you would, in order to comply with regulations, likely need to run a full regression test every single time. Outside of that, you may or may not need to. It depends. But these are questions to be asking. System architects, can the systems that you create actually support green practices? Are you creating them with a mind towards efficiency? Sometimes monolithic servers can be more efficient than having 1,000 microservices. It really depends on what you're trying to do. In general, loosely coupled services are a better way to approach things. But, if you have one thing that does one thing, and that's it, have your monolith be a service. So what are some practices that we can do? Well, first off, we want to have good metrics. There's been a lot of people over the years who have had attributed to them the idea that if you don't measure it, you don't know it. I did a little bit of research, and Lord Kelvin, as best we can tell, the first person to be recorded saying it, or something along those lines. Lord Kelvin was also very verbose and known for using 5 words when 2 would suffice. But it still was an interesting little exercise trying to find out who actually had said it first. Good DevOps practices, 3 ways: infrastructure as code, metrics. Now, there's 2 reasons why you want to have metrics. One, so that you know, hey, we are showing improvement here. 2, or this particular place needs a little bit of improvement. But you can then go to management and say, hey, we know that you're starting to have this reporting, or we know that you're pushing to cut down on costs. Here is something that we did by making this piece of code more efficient, by turning off servers at night, and so forth. Here are ways that we are saving money. Here is how we saved it, and here's how much we are saving. Having good metrics really can make a difference. Cloud optimization. Have auto-scaling services. Use your servers as efficiently as possible. It's having a CPU running at 95%, as long as it doesn't overheat, is not bad. You want to make as much use out of it as possible. Now, there could be other constraints. One place I worked, the capacity planning group had, for years and years, lived in a world where CPUs were the limiting factor. Well, with Java app servers, it turned out that RAM was much more of a limiting factor, especially since all of their applications were IO bound. So, I would be saying, hey, this server is about full. They would look at it and say, well, the CPU utilization is only hitting 15%. What's going on here? But they were running at 90% RAM utilization. So, knowing what your systems do, knowing how things are working makes a huge difference and allows you to use your equipment more efficiently. Use energy efficient hardware. At this point, compared to other resources like the CPUs, your machines, your servers, networking costs as far as energy is basically nothing. It is much less of an issue or a user of resources than those other areas. How are you disposing and recycling of your equipment? Practice sustainable coding. Streamlined and efficient code reduces processing demand. Choose good algorithms. There was a project, and this is a while back, where it had originally been designed by a OO purist, and they had their system set up that it's a workflow, linear, with one small branch off to the side. They would pull something off of a queue, process it, put it back on the queue. Step 2 would take it off the queue, process it, put it back on the queue. They were blowing through 3 gigabytes of heat every 2 seconds of allocating and deallocating. Now, this was in a Java environment, but still, they were spending all of their time taking things off the heap, unmarshalling it, then remarshalling it when they put it back onto the queue, and so forth. So I was a part of a team for best practices at the time, helped them rewrite it. It took a few months of, browbeating before they tried, and they improved their performance by 40%. Just from changing from a not so good architectural solution to one that was a bit more pragmatic. And interestingly enough, your language choice matters. Now, this is not taking into account the individual costs of developers and how long it might take to write something and so forth. But this is doing a bubble sort, and I chose a bubble sort because it's simple and easy to implement, and everybody probably has heard of it. And it's compared between 5 different languages, and at 1 million records, it took anywhere from 20 minutes to 21 hours to sort those 1 million records. And it's the same code, the same data set, running in the same container, on the same laptop, and nothing else was running on the laptop at that time. So, we're talking a 60-fold or up to a 60-fold difference. And I'll admit, I was really surprised at how efficient Java was compared to how it used to be with it. But again, choosing a language just because it might be more efficient here, you could fall into the trap of premature optimization. And you may end up costing the company a lot more money for something that doesn't really need to be heavily optimized. So pick some green hosting options. Choose your providers based off of their commitment to renewable energy, to green cooling, and so forth. Smart testing. I mentioned that previously. Resource management. How many copies of a piece of data do you really need? Now, you might be required by regulatory to maintain data for several years. It really depends. In your network traffic, are you hopping from machine to machine where you don't necessarily need to? These are different things to ask. Am I using the CPU effectively? Am I using memory effectively? Going back to that previous, Java used more RAM than any of the others by quite a bit. 3 or 4 times plus more RAM than the others. So that could be a consideration to take into account. Again, a lot of these are understanding what our systems are doing and having lots of tools in our toolbox. Continuous improvement. Find a pain point, reduce it. Doesn't have to be a big one. Measure the impact. Find something else that's painful and improve it. This is partially Agile methodology, partially DevOps, but it's just a matter of, choose some low-hanging fruit. Do something today. A lot of people get caught up in having to spend lots of money, lots of time building out, various and sundry, say like a CI/CD process, or just change management process, where it might be that a set of Post-it notes is good enough for today, and you can have it implemented in a couple hours and documented and so forth and so on. So, is it better to have that today as opposed to waiting 18 to 24 months for something that may never happen, for this tool that will supposedly solve all of your problems? So why do we want to do this? What are our benefits? We're going to reduce our operating costs. There was a survey done last year of engineers and managers, and a majority of the engineers felt that you should be doing sustainability practices for benefiting the planet. Management, on the other hand, approached it from a reduce costs. We can avoid regulatory complications. We can have a positive environmental impact. We can have an enhanced reputation. Now, there are certain states, such as Texas, that have said that they will not work with companies that do ESG reporting. This is going to be really interesting to see what happens when the SEC mandates reporting and when companies or the Texas government wants to work with companies elsewhere that have regulatory requirements for doing ESG reporting. So it will be very interesting. And I don't want to go into politics here, but it will be interesting to see what happens in the next year or two in this country. So in conclusion, sustainability is not just a trend. And I'll admit, I'm a little ahead of the curve, but it's becoming more and more important. And a number of larger companies, such as Dell, HP, and others, Amazon, Google, are really getting involved with sustainable IT and sustainable software. Everybody in IT plays a role. And by making small steps, we can make a big change. Only you can promote sustainability. A quick advertisement. There is now a sustainable IT meetup, which I run. We are virtual. And next week, next Tuesday, we are going to be doing a green workshop where we look at a architecture and an application, measure places where it could be better, and then identify things that we can change to improve its performance. So basically, a workshop to start people to become aware, then become conscious of, oh, here we have this inefficiency. Here we have another inefficiency. What can we do about it? And then help people to learn the skills of how to go about changing it. And that's the gist behind the workshop. Any questions?
Yes, there is one from Rich in the chat. Are
All
the
right.
older algorithms that were designed to run on limited system resources more energy efficient than what we can produce today?
It depends. So I'm saying that, half tongue in cheek, but it really does. Everything really depends on your data. And frankly, everything we do in IT is data driven. We have an input and we have an output. And what we do in between really depends on, what our customer have requested of us, but also what shape the data's in. So for instance, like the Peacock hash that I mentioned earlier, that's a newer one. And so that would be more efficient than older style hashes that would need to be rehashed on a regular basis. So it really depends. Quicksort is considered to be generally the fastest sort that is in common use. But for already sorted data sets, it's bad. It's really bad. Bubble sort may actually outperform a quicksort if you have a pre-sorted set of data. That actually would be fun to see. I'm curious now on that one. But some of the other things that we're practices when system limitations existed that we don't have nowadays, like an indexed sort. So in an indexed sort, you have your set of data off here on the side, and you are just sorting pointers. You're not moving the data. And so that's much more efficient than other searches where you're moving the data around. So something like that, that's an older practice, definitely would be more efficient. Well, I don't want to say definitely. I'm sure that there's some case where it's not. But generally, that would be more efficient than, as you're doing your sort, moving blocks of memory around. Because memory costs, transfers are relatively expensive. They're not the cheapest thing in the world. But, if you're moving a 4-byte pointer as opposed to, kilobytes or megabytes of data, then that's going to be a lot more efficient. And I'm going to put up the QR code again. Any other questions?
Yeah, looks like there's a follow-up there, Matt. Should we be writing code as if we're working with limited system resources?
Well, in general, I would say yes. And here's partially why. I've seen, and I'm going to pick on Java developers, this being a .NET users group, but I am sure that, .NET and C# developers have their own foibles. But I've seen way too many times where a developer will create a hash of hashes. So you have a hash that has numerous other hashes embedded within it. And every time you have a hash, there is overhead. So you're using a lot of resources that you wouldn't need necessarily. Now, that said, if you're doing a one-off, it's only going to be run once, and you really don't care too much about, how long it takes to run, then, use decent practices, but you don't necessarily have to be totally conscious of it. You know, it's all about, picking your battles and being making better choices where appropriate. Another place that I'm surprised I didn't have listed here was, have the DBAs check all of your SQL statements, all your database queries, because that's another place where there's always going to be some inefficiencies there. I once ran into an issue where a team had released a project and it ran great, ran fast. But 6 months later, it was getting slower and slower and slower. And so the issue was for their connection pool to test the connection, each time they were doing a count of a table. And this table grew over time. So, when there's 10, 15, 100, 1,000 elements in it, it works pretty good. You get up to 1 million, 10 million, etc. You're doing full table scans every single time you check out a database connection. So, I can write SQL. I'm not great at it. It's not been my focus. Pick on the DBAs that, really know what they're doing and how to tweak the most performance out of their database. And it's going to depend database to database. So again, it comes back to knowing your systems. Can I? No. There, I got the chat now. Let's see here.
I think that's all
Nope.
that was in the chat. Is there any other questions for Matt?
I'm too lazy to type, so I'm going to ask verbally. Um,
You speak up.
sorry, can you hear me now? Is that better?
Yes, it is better.
Okay. I think I get that. I would think that the onus of contributing to sustainability would be on both sides, developers and what I would call corporations in the government.
Hmm.
But it would seem to me that, well, maybe this is my question. Do you think that the primary onus is on the developers or on the corporations, and who should start that process?
Okay.
Because the reason I ask that is I don't see me, the individual developer, controlling what IBM does because I'm just a cog in the wheel, even though I don't work at IBM, but you know what I mean.
Right. So ultimately, and I'm going to approach this from two different directions because I think that the onus is on both parts. Individual developers, say, have a responsibility in how they develop their code to, work efficiently, reduce costs, and so forth. That said, ultimately, all of these things are business decisions. And ultimately, the business makes the decision, but that doesn't mean that individual contributors can't make a difference, can't have an effect for the better. So I don't think that there's any one answer to that because this is definitely something that can be driven by grassroots, but unless upper management buys into it, it will only go so far. Uh, you know, as regulatory pressure comes to bear, you will see more of it being driven by the organization, by the business. Simply because in order to remain compliant, they'll have to do it. If they want to, for instance, be able to operate in Europe, they'll have to be compliant to the regulations. So I really personally think that it's a two-pronged approach. There's the prong that, the individual contributors, the individual teams can do. And, how often has somebody gotten yelled at for saving money? Doesn't happen very often. So to that end, I would say that, it really is both. But until you get both individual contributors and the business working together, you'll see limited traction. Because how many times has, upper management come in and said, CTO or whatever, they were at a conference last week and they heard about XYZ, and XYZ is the fastest and best, and we have to do it now. We have to have XYZ. They don't know what it does, but we have to have it. And so these, mandates come from on high, and of course there's going to be pushback. In the midst of all of this, there has to be really good change management. And here, I'm not really referring to, when you submit code, for that sort of change management, but in terms of organizational change, in terms of the culture change, that needs to be managed very, very well. And unfortunately, most organizations suck at change management because you have to keep it in mind at all times. I have seen where every manager in the company supposedly went through a change management workshop, a several-day workshop. And then upper management made some very indiscreet and ill thought out, at least from what their description of why they were doing it, decisions. And so they really lost the opportunity to manage the change effectively. And as a result, had a lot of disgruntled employees and brain drain. So, like everything else, it depends.
Okay. And then I have two quick questions. I assume that there is no body or document sort of with standards currently supporting sustainability.
Yes, there are.
There are. Oh.
There are. So the Green Computing Foundation's working on one. SustainableIT.org has a set, but they are primarily looking at it from the power, water, cooling standpoint, those sort of things, supply chain. So those are some of it. There is also some, let's see, some tools. There's more than this. Let's see here. There's also GRI, which was one of the first sets of standards for it. EDPR, I think it is, from Europe that they've now released. India will have their own. California has their own. There's also the UN's 20 Principles for Sustainability. So there are some. Right now, there isn't necessarily a leader coming out of it. Now, there are some mappings from some of the standards to other formats, so that if you do your compliance checks and reporting in one, you can then reformat it so it'll map over to the other. But it's still pretty new. There's still a lot of exploration going on there. Yeah, there's.
Okay. That makes sense, because my question number two was, do you just happen to know why they're still using water to cool instead of gas, or gases, I should say, like they do with nuclear? Why are we still stuck with water?
They use water in nukes. They use a lot of water in nukes.
I thought that they had primarily all switched to gases for cooling. Are they still? Oh, somebody told me the wrong thing. Okay.
Yeah, so like for instance, water is a good damper for radiation, and it's really good for cooling things down.
Yeah, I thought gases were better though than cooling down than water.
It depends on
No?
the gas. The
Okay.
other issue that you have with gas is, as the temperature changes, the volume changes proportionally.
Oh, yes. Okay.
PV equals nRT. So pressure or let's see, PV equals nRT. Volume over the temperature, or temperature over volume, is one changes, the other changes proportionally.
Okay.
So I know that, like in our Navy, they're using a lot of water. Of course, they are also using power plants that are a bit different than what's used on land and in civilian instances. But, like in Chernobyl, for instance. They had an issue where the pumps weren't circulating the water properly and stuff overheated.
Oh, that's what
And
caused Chernobyl. Okay.
that's the Reader's Digest, but yes.
Got it.
Um,
Got it.
yeah, that the water wasn't getting pumped properly. Whether it was because there was a faulty sensor or because the pump broke down, I don't remember. But the reactor core overheated, turned what water was there to steam, and continued overheating, and about melted down.
Yeah, I remember that. That was a really horrible, people dying, as I remember, not everybody, and then them having to clear out the town or whatever.
Yes. Yeah. And then Fukushima, they had the issue there with the tsunami and such, that water that was already in the reactor got mixed up with seawater, and so there was a radiation leak because of that.
Oh, lovely.
But
Okay.
yeah, so yeah.
Great question, says Sam.
Thank you.
One interesting thing that Facebook did back in the early noughts, they opened up or maybe around 2010, they built a data center up at Niagara Falls where they used passive cooling. And they would open the windows, and there was enough of a breeze that the air would circulate so that they were not having to use water for cooling purposes.
Oh, good for them. Didn't Google try to do an underwater data center in the bay in San Francisco, or they tested it on a ship or something like 10 years ago or 20 years ago? I don't know.
It may not have been Google, but there are some different groups that have done so. There was also Sealand, which was based off of a old platform for artillery and spotter for German planes during World War II. That down underneath, they built out a data center. There was a problem with a fire though, so that basically closed that down. But yeah, the ocean makes a decent heat sink, but you have infrastructure issues with it.
Oh, yes, because you've got all the potential leaking and air, water exchange. Yeah, that would make sense. Seems nothing's perfect, right?
You can thank the second law of thermodynamics for that. There's you can only reduce entropy in a closed environment. So say if you have a heat pump, for instance, within your data center, you can reduce the heat, the entropy, but you're doing that by pumping the excess heat out into the universe.
Okay. And then you're affecting, the environment around you. So,
Right. So if you ever put your hand near an air conditioning unit when it's going full speed in the summer, it's hot.
oh yeah, I've never done that. Oh, okay. Yeah, that would make sense.
So yeah, there's no one answer. Nothing's perfect. It's a matter of trying to do better.
Okay.
Yeah, absolutely. Well, and on that note, we are at time, but this has been a wonderful discussion. Thank you so much, Matt, for coming back and talking to us.
My pleasure. And it sounds like there might be some interest in the algorithm talk at some point.
I would be down for that.
Okay. I'm happy to come back. It's language agnostic.
Wonderful. Yeah. Yeah, we'll keep in touch and get you booked again sometime.
Sounds great. Well,
All
thank
right.
you
Thank you very
everybody for
much,
your time.
everybody.
Yeah, have a good night, all. Bye.